Now, in the protein design side, as I mentioned, in the early days, we were doing libraries and more display-based discovery technologies. Fast forward to today, and we are now using de novo methods in a computer. So we can design in a computer entirely de novo binders that go against these targets. And there's several companies out there that can do this. It's becoming a pretty crowded space in some cases. You're almost hearing about some new update every week. What's cool about Manifold is when we design these, we also have the capacity to now measure these at a very, very high scale in the most relevant in vivo system. So we recently, for many years, we were at sort of the 50 to 100 plex scale of the in vivo scale, which is 50 to 100 times more than anyone else could do. We've recently had a breakthrough where we can now do over 100,000 plex simultaneously in a single experiment, and it's a bit of a coarser measurement, and there's obviously some trade-offs that you make when you go to that scale, but it's very powerful because in a computer now you can design these binders in silico, but now with the in vivo measurement, we can actually go and get labels of which of these molecules are actually enriching in the tissue that you designed them for, and you can go back and say, that structure, that predicted structure, is now more likely to be a real structure. And that insight, it's sort of, I think a lot of the field is very excited about AI to speed up discovery or, save some time here and then maybe save some cost. That's a reasonable benefit. But one of the understated benefits, and something we talked about inside of Manifold, is by having that feedback from an experiment to tell you that a structure is real, and to do that at the scale of thousands of structures simultaneously, you are able to now make iterations and decisions based on that structure and really learn about the structure tells you the epitope, the affinity. You can potentially predict additional properties about that molecule. But now you have information about what that actually does in a living system. And that closing that loop, that data piece, is something that we think is really important. So we really emphasize the data moat in our unique data type that we're able to bring to this space and complement with our innovations and other innovations in the AI protein design space.